This is the method I use to solve the 4x4 intuitively, without any written or memorized algorithms. The only thing you need to know to use this method is how to construct commutators. My main goal in making this method was to be able to solve parity problems at their source with a single quarter turn rather than using a long algorithm at the end of the solve. This makes the method pretty move efficient and I think really fun. The method has 6 steps, and there's a link in the description to a detailed explanation of all 6. The first step is to solve 1x3x4 blocks around opposite centers, similar to the room method. Since I'm so slow at cubing, I'll summarize the rest of the method while you wait for me to finish this step. After I finish the first 2 blocks, I'll solve the top layer corners, and since I don't know any corner algorithms, I'll use a commutator for this, combined with a simple heuristic to make sure that the corners have even parity before I execute my commutator. Next, I'll extend one block to a 2x3x4 block by solving 3/4 of one middle slice. Then I'll use the unsolved slice to solve 7 of the last 10 edge pieces. This puts the last 3 edge pieces in an even parity state which can be solved with a commutator instead of a set of last edges algorithms. Finally, there will be about 7 center pieces left to solve with 2 or 3 commutators. Once block building is complete, I have to solve the corners with a commutator, which means that I need to put the corners in an even parity state because commutators can't solve odd parity permutations. I check corner parity by permuting one corner correctly and then examining the permutation of the other 3 corners. Exactly 2 of the 3 corners are out of place, which means that the corners have odd parity. All other cases of 3-corner permutation have even parity. To convert corners to even parity, I solve one corner using an odd number of quarter turns. Here I do it in 1 quarter turn. I can then solve the remaining 3 unsolved corners with a commutator. Now I extend the left block into a 2x3x4 block by solving 3/4 of the left middle slice. I do this by pairing edge and center pieces in the top layer, and then inserting them into the slice. First, I pair red centers with the red-green edge, insert them, then pair the green centers with the other side of the edge and insert them. Finally, I pair orange centers with the green-orange edge and insert it, completing my 3/4 slice. I leave the right middle slice unsolved so that I can use it to solve the edges of the top layer. I do this by pairing opposite edges rather than adjacent edges, and then inserting them into the top layer. For example, the white-blue and yellow-blue opposite pairs that I solve here. You can solve any 7 of the last 10 edge pieces. This leaves 3 edge pieces unsolved, which will always be an even parity state that can be solved with a single commutator instead of a set of last edges algorithms. Here, I leave the last 3 edges in the same slice. All cases like this can be solved with the same commutator or its mirror, which makes the last edges very easy. The last step is to solve the remaining center pieces. In this case, there are 7 unsolved pieces, which I will solve using 2 commutators. The first is a 4-move commutator, which will solve 4 pieces. Even with a long conjugate, this is pretty efficient. Finally, I solve the last 3 pieces with an 8-move commutator. When I'm trying to be efficient, I average about 110 moves with this method. In this solve, I was not really trying to be efficient, so it took me 123 moves. This solve is actually my fastest ever at 4 minutes and 20 seconds, which is a little less than half a turn per second. As you can probably tell, I'm not a speed cuber, so I'm sure that you could do much better if you gave it a shot. Well, that's my method. I hope you have some fun with it. Thanks for watching.